Hey, listen to this carefully. I have age variable, which is X variable, and I have the buying variable, which is Y variable. Buy takes two values. There are some zeros, there are some ones. So zero means a person is not buying that product. One means a person is buying that product. Maybe the product can be anything. It can be as simple as a ice cream, or it can be a very big product like buying a car or buying an insurance or taking a loan or something like that. So buying the product, and age is somewhere like you have age of 3, 4, 5, 10, 15, 20, and so on, maybe till 100, maybe age is there. Now age takes some value, whether this particular person who is age 35, whether he will buy the product, age 12, whether he will buy the product, age uh, 35 again or 36, whether he will buy the product or not. Buying and not buying are the output. Now look at this carefully. When age is 4, the predicted value is minus 0.086. I know that from my data, 0 means not buying, 1 means buying. Only these are the two values that are there in my output. In my output, there are only zeros and ones. 0 means not buying, 1 means buying, or whatever may be the meaning. But what does negative minus 0.866 means? What does this customer do? Tell me, how do you interpret this prediction? How do we say, is this customer going to buy the product or not buy the product? What does a negative value mean? 0 means not buying. That much I know. Minus means what? Does that mean refunds? Like giving us the money or selling us the product in return or something like that? What is the negative? Do you have the negative values in past? Never. So there is something wrong here with this, because we never had a negative value in the data. Again, 0 means not buying, 1 means buying. When the age is 105, the predicted value is 2. How do you interpret predicted prediction of 2 here? Tell me. What is the meaning of predicting 2? Does that mean buying two products? Can we comfortably assume like that? 2 means buying two products, 3 means buying three products, like that? No. No, we have output as zeros and ones only. 0 means not buying, 1 means buying. There is something wrong here as well. There is something wrong here. We are not able to understand that. When the predicted value for age 4 is giving as negative, and we don't have any negative value in the original data, predicted value for age 105 is 2, but we never have this class 2. We have only two classes like zeros and ones in the output. There is something wrong. There is something grossly wrong here. You know why we are getting these results? Here is the reason. Your data is like this. Your data has zeros and ones. 0 means, let's say, not buying the product. 1 means buying the product. Do you have anything else in between? Do you have 0 0.8, 0 0.6, 0 0.4, or 0 0.5, or 0 0.25, 0 0.3? Nothing. I have only zeros and ones. Nothing else I have. Isn't it? The output is just zeros and ones. The output is not continuous. The output is discrete. The output is categorical. Category 1, class 1, class 2, that's it. Class 0, class 1. You have only two classes in the output. The output is not continuous. Till now, the output was continuous. Number of passengers, loss percentage, etc. The price, etc., etc. They were all continuous. But here there is discrete. Your full data is like this. The data that you are working right now currently, this is the data. This is the data that we are working on. The x-axis there is age, which is going from 0, age is 2, 10, 15, 20, 25, 35, 40, 55, 60, 70, 80, 90, and so on. This is the age value, whereas the target variable output is taking only two values. And for this data, we built a linear regression line. Can somebody tell me what exactly linear mean? Linear is a mathematical term. In simple terms, what does linear mean? Linear. A perfect way to say it is straight line. Linear means a straight line. Yes or no? Linear. Something is linear, going straight. So we built a straight line model for this data. You have built this model for this data. Do you think a linear regression is a good fit for this data? Do you think a linear regression, no matter what optimization you use, no matter how great technique you use, no matter what you do in the background, do you think this straight line will go through all the points in this data? Do you think a simple straight line is a good representation of this data, or do you think a linear regression fails in this case? Do you think when the output is just zeros and ones, do you think linear regression fails here or not? I think linear regression is not a silver bullet. It will work on every type of data. Here is a simple example where you have zeros and ones in the output, where you have classes in the output. Output is not continuous, where you have only zeros and ones in the output. Your linear regression line fails. This is our first case where linear regression doesn't work. Since the linear regression line failed, that was the reason why we were getting all the wrong predictions. So linear regression line is not a good fit for this particular data set. In fact, in real world, there are so many such examples in gaming based on several properties of the players, based on the ground properties, based on the statistics of the players. You want to predict whether this game will be won or lost by a particular team. In sales, based on the customer profile details like customer age, customer income, customer expenses, customer number of cars, etc., etc., you want to predict whether the customer will buy your insurance or not buy. In marketing, again, based on the customer properties, based on the customer profile details, based on the customer on book data, etc., etc., you want to predict whether the customer will respond to your marketing call or not. That's it. Simple. Whether he will respond or not respond, buy or not buy, win or loss. There are no several options here. Simple, this side or that side. In credit cards and defaults, based on the customer financial historical data, I want to predict the customer will be defaulter, bad customer, or good customer. On websites, based on your click stream data, what websites you have visited, how much time you have spent on each website in last 2 hours, what was the most clicked web page, what was the, how much was the time that you have spent, etc., etc., how much time you spent on social media website, how much time you spent on news websites, etc., 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 etc. I want to predict whether I should show this ad or not, whether you will click on this ad or not. In operations, whether the customer will attrite or retain, or whether an employee will stay back or attrite. In fraud identification, based on the type of transaction, based on the amount of transaction, somebody has simply swiped right now, based on the amount of transaction, based on the type of transaction, based on the type of product that you are buying, based on the time that you are buying, based on the place that you are buying, based on all these details that can be simply extracted from a simple swipe, I want to predict. What do I want to predict? Whether this particular transaction is a fraud or non-fraud. That's it. Do you think we are interested in amount of fraud, or what is our top priority? Tell me. Is it amount of fraud that is top priority, or fraud or not fraud? Is that classification of fraud or not fraud? Which one is top priority? Tell me. Do you think an amount is simply $2? $2 is the fraud amount. Shall I say it is just $2? Shall we let it go? Do we do like that? Do you think company will do like that? Fraud amount is very small. Let it go. Let us accept the fraudulent transaction. Even I know that. No, it's a security breach. $2 may be a small amount, but it's a huge security breach. So fraud or not fraud is my top priority. Maybe amount of fraud also I'll focus on, but later on. Yes or no? Fraud or not fraud in healthcare, cure or no cure. In fact, 90% of the problems 90% of the problems in this data, they are classification problems. What is classification? When the output is categorical, whether this class or that class. In fact, you can have multiple classes also, whether class 1 or class 2 or class 3 or class 4 is what you have to predict. We will reach multiple classes later on. As of now, you think binary classification, whether this or that. In this output, if you have two classes, binary classes, then linear regression fails. Why it fails? Because of its own property, because of its basic property, that it's a straight line, and we cannot fit a straight line that will go through this whole data. Are we really serious our data is like this? Do you think our data is like this? Yes, let us go through our data. Usually you don't need to draw such lines and all that. In reality, nobody draws the regression line and shows it. But to understand here, using this simple data, actually we can draw the regression line and the data, extrapolate regression line on top of it. We can check that our data is these blue dots and this green line is our regression line. Are you with me? Are you convinced with the fact that we should not build a linear regression line here? It has to be something else which we haven't discussed yet. But linear regression line fails. Are we clear on that? Let me know.